Hello, audience. My name is Aaron, and I'm 13 years old. And today, it is my pleasure to host this show today. I'm from Stratford, but I'm also for Able to Shine, a soft skills educational program. We help you shine. Why wait in line? Now it's my honor to introduce our fellow judges, Dr. Yu Pan, Dr. Tony Xie, and Miss Noelle Lawrence. Welcome, our wonderful judges. As you know, we have some rules for our contestant to follow. The max time for each project is 15 minutes. And we have to save at least 5 minutes for the interview from the judge. And without further ado, let's begin the showings. Do you ever wonder what the life of a star is like? I've always wondered, but you guys are probably thinking of celebrities, those attention getters, the glitz and glamour, Taylor Swift, Justin Bieber. But no, I'm talking about the real stars here. Me, the suns, and the stars of other galaxies. I'm here today. Zachary Liu is here to present his show, The Life and Death of a Star. And I'm so excited for it. I can't wait to get know more about stars. So without further ado, let's welcome Zachary Liu to the stage. And we have Alicia Liu and Jason Feng on standby.
Good evening, everyone. My name is Zachary Liu. I'm fourth grade at John Muir Elementary School. Today, I am presenting Life and Death of a Star. Main ideas: how stellar nebulas are formed and what they can do. When do the planetary nebulas happen? Why they happen? What they can do. Why supernovas are bigger than planetary nebulas? How do they happen? What is inside them? When do you know when they happen? Every star's life and death on the last pages. These are pictures, some pictures I drew with my hand. This is the whole project I made with my hand. This is a mini map I made, and this is stellar nebula and planetary nebula, and supernova right here, and life of a star over here, the last 2 pages. Introduction. I'll introduce stellar nebula and planetary nebula on the first page. Stellar nebula and planetary nebula. Supernova on the second page, and life on the and death on the star on the last 2 pages. Stellar nebula and planetary nebula. Every star is formed by a stellar nebula. Stellar nebulas contain dust, mist, gas, vapor, fog, smoke, helium, and hydrogen. Stellar nebulas are formed when the interstellar medium undergo gravity collapses. Stellar nebulas can start as 2 things. Massive stars are blue. Smaller stars like our sun are orange because it isn't as hot as the massive star. Stellar nebulas are so big that they can create more than 1 star. Planetary nebulas are formed when the bigger form of our star, sun, ends its life by shooting out its outsides and leaving its hot core, the white dwarf. Planetary nebulas are made out of gas, plasma, fog, vapor, dust, electric, fire, helium, and hydrogen. This is a picture of the stellar nebula I drew, and this is how it's formed right here, and this is what it's made out of. This is the planetary nebula, and this is how it's made, and this is what it has inside it. Supernova. Supernovas are made out of gas, plasma, heat, fire, dust, helium, hydrogen, carbon, energy, and other heavy elements. When supernovas happen, the core of the massive red giant gets so crunched by gravity so closely together that the repulsive form of their nuclei create a recoil after the squeezed core. and with a single bounce, everything explodes in a supernova. Either it can turn into a super dense neutron star or even denser star named a black hole. If it's a neutron star, that means gravity won. If gravity loses, it will turn into a black hole. This is a picture of the supernova I drew, and this is how it's made, and this is what it is out of. Supernovas turn into neutron star or a black hole. If gravity wins the supernova, it will turn into a neutron star. If it loses, it will be a black hole. Black hole's gravitational pull is so strong that light can't even escape it. Life and death of a star. Every star, is formed by a stellar nebula. Or it can also be formed by a different star. It can turn into an average star or a massive star. Average stars will turn into red giants after swallowing different stars. And then it will turn into a planetary nebula. Soon the planetary nebula will fade away and turn into a white dwarf. Very trillions of years later, it will cool down and turn into a black dwarf. And then it will die. Massive stars are bigger than average stars, but not bigger than red giants. It will soon turn into orange, and then very orange, and then red. And then it will form its iron core. It will get crushed by the planet and also gravity. Then it will all explode out in a supernova. It can turn into a neutron star or a black hole. There's 4 different types of black holes. Primordial black holes are formed before atoms. Some of them are even older than atoms. These primordial black holes can be formed when an electron is heavier than other electrons. Then it will turn into a primordial black hole. It will form inside the electron. Then it can turn into a normal black hole formed by a supernova. It can also, its gravitational pull is also so strong that light can't even escape. Primordial black holes are way stronger than every other type of black hole, since they are the smallest. The smallest can be very dangerous because it can crunch you in less than a second. And then supernova, supermassive black holes. Supermassive black holes can be formed by quasi-stars. Quasi-stars are yellow and formed by brown dwarfs. Brown dwarfs are also formed by stellar nebulas, but they are very rare, so they rarely ever happen. And then the biggest type of black hole is ultramassive black holes. One of the biggest is 10618, the biggest black hole known yet. It has also, I forgot to tell this, but if there's a supermassive black hole and it grows very big until it's super big, it will shoot out rays of plasma. Also, they are very blue. Ultramassive black holes event horizon is blue because it's harder than the normal event horizons. Also, it's less dangerous than the other black holes. Since it's the biggest, it has a longer time of like crunching. Ton 618 can fit three whole solar systems side by side and still swallow it whole. Neutron stars can die from just losing too much mass or just colliding with another neutron star. If they collide with another neutron star, it will turn into a kilonova. Kilonovas will spew out a lot of heavy materials like gold and uranium and titanium and other stuff. And platinum too. Or this neutron star can also get swallowed by one of these black holes or die from strange matter. Strange matter is a green thing that lives inside a neutron star. That's why it has so much dots inside it. It's because of all the strange matter inside it. Neutron stars can die by strange matter because it can turn other atoms into strange matter. Strange matter is like a zombie apocalypse, where it's just way stronger and infects very fast. Once it infects the whole entire planet, it will explode. And if one of those strange matter collides with Earth, then it will destroy probably 30% of the Earth's
Time's up.
atmosphere.
Time's up.
Okay.
Judge, it's time for questioning.
Okay. You can ask questions now.
Hi, Zachary. I'm Dr. Pan. Great job on the research and presentation. I'm really enjoying the diagram. Did you draw this, or actually you drew with some of your friends together?
No, I did it all at home with my hand.
Oh, okay, okay. So it's amazing. So my question is, as I'm learning so much, where did you find the knowledge or the information you just share with us?
Well, I found it on the internet, and also like this guy, I forgot his name, but he knows a lot of things about like stars. He knows a lot of things.
Okay, this guy online or this guy that in real life?
No, that guy is real life.
Oh, in real life. Oh, okay, okay, great. Great job. I really enjoy it. And how did you memorize so much information? I'm just curious.
Well, I read it many times, so that's how I remembered it.
Yeah, great job.
And also I drew this picture 2 times. One of them, I sent it to my teacher, and it's now at 3rd grade. It's at 3rd grade place for the lower grades to see, and they can know my knowledge.
Yeah, it's so helpful. I learned so much from you. I don't think I have ever learned so much about stars until today. Thank you, Zachary. Great job.
Thanks.
Do any of the other judges have any questions?
Yes.
Okay, you can speak.
Hi, thank you. First of all, I want to say hello, Zachary. Hi, how are you?
Pretty good.
Wonderful. You should be. You should also be proud of yourself. You did a great job with your project. I wrote down some notes, and I'm going to try to say them a little bit quickly because I know we're pressed for time and we want everybody to have enough time to present their projects. Are you okay if I give you a little bit of feedback?
Sure.
Yeah, sure. All right, Zachary, let's do it. First of all, I can tell that you're very passionate about this subject matter. It shows, and you really put a lot of effort into your presentation. And it's also very well organized, which is very pleasant. Your slides are fantastic as well. I also enjoyed how you were able to, at the beginning, introduce the topics that you're going to talk about. That's how you should present presentations. And it's helpful for your audience to know what to expect and to better understand the information that you're giving and to better also remember it. It also helps if you run out of time, at least people know the points that you were going to make. So it's not completely all lost. So very good about that. I love that your drawings are handmade. I do have a suggestion for you. This is a high school level suggestion. So do not be hard on yourself for not having done this. But in the future, I would love it if your handwriting was capitalized. When you have a project, especially if it's going to include graphics, and even if they are handmade, capital letters are easy to read from far away. That's why when your parents are driving their car, if you look at on the highway, all the signs, nothing is lowercase. Everything is capitalized. So that allows for the viewer to understand from far away, or even if it's a small picture on Zoom, what exactly is going on. Because you put so much work into these drawings, and I see it says Red Giant, and then I almost can read some of the other stuff. I see Supernova, but I hate for your hard work to be lost. So in the future, that's something that you can do to make it really pop. Otherwise, it's fantastic. You also color code it, which I'm a very visual person, and if you can't tell, and I appreciate that. Thank you for defining I'm going to continue. Thank you for defining the difference between the stellar nebula and planetary nebulas. And I like how you were able to emphasize every star starts with a stellar nebula. Am I correct? Yeah, okay, good. Just making sure I'm not saying the wrong one. And I have some more information, but I'll leave that for the notes in your judging form. And then I agree with Dr. Pan about where did you source your information. We have to be careful where we gather our information. The internet is, it could be a double-edged sword. It could be a place where you find, say that again?
It can also lie.
Yeah, so there's something called peer-reviewed studies or double-blind studies, which means like I have this experiment and now I'm going to give it to this school and they're going to do it and check if all my things are correct. But we'll find out about that later. Other than that, your project is fantastic, and I really appreciate all the time that you put into it. And thank you so much, Zachary.
Bye.
Okay, bye. Nice to meet you.
Does the last judge have any questions?
Yeah, I don't have any questions. I think it's a great work, and yeah, it's great work for elementary school student.
Okay, then let's move on to the next. Let's move on to the next presentation. Do you ever play rock, paper, scissors?
Hello, Aaron.
Yeah.
So this is Lindsay from CASPA. So I have some words to the judges. So after each presentation, we may have several minutes. So please, Aaron, give the judges 7 minutes for them to submit their judge form. So you can check with me because I can see whether judges have submitted or not. So you can ask CASPA whether the judge has submitted or not. After judges submitted, we can go to another one. Otherwise, judge may need some time to think about it. Yeah. So now I can see 2 judges have submitted. maybe we can wait a little bit.
Okay, we'll wait until the judge submits it. The judge that didn't submit, inform me when you're done.
That would be me. I just need a few moments, okay?
Okay. Also, great job, contestant, on your presentation. I really liked it. The drawings were super nice, especially for an elementary schooler.
I really appreciate it.
You can get started with introducing the next person, and I'll send it shortly.
Okay. Now let's introduce our next presentation. Do you ever play rock, paper, scissors with your sibling and you keep on losing? Like, it's so annoying. Well, it never happens to me because I never lose. I'm the best at rock, paper, scissors. But for those strugglers out there, the next presentation might be worth listening to. Today, Alicia Liu and Jason Fenn will present a mathematical way of having a high probability in winning in rock, paper, scissors. So without further ado, I've been waiting for this. Let's get started. Presenter, we can't see your screen.
Now can you see my screen?
Sorry, all we can see is your desktop.
Okay.
We can't see the slideshow.
Wait, hold on. Now can you see it?
Did you share your screen?
Yeah.
Oh yeah, now we can see it. Continue with your presentation.
Okay. Hi, my name is Alicia Liu, and I'm going to be presenting our research project, How to Win Rock, Paper, Scissors. Rock, paper, scissors is a popular game people play. And people play this game to settle disputes and decide on situations like who cleans out the trash and who cleans the dishes. When I play rock, paper, scissors with my brother, I almost always lose. So, and every kid wants to win. So that's why we chose this topic. In this research, we want to uncover the answers of the following questions. What different strategies are there to win rock, paper, scissors? And do people play rock, paper, scissors randomly, or do they follow some patterns? We designed 4 types of ways to play rock, paper, scissors. Normal play, blind play, computer random play, and computer strategy play. Normal play is when the 2 players just play regularly, and blind play is when one of the players have to cover their eyes during the game. Now I'm going to introduce you to computer random play. In the experiment, one player plays the computer and the other is a normal player. The random rock, paper, scissors generator we used was coded on Scratch by Raymond. And this is the generator. So when you press the go button, it generates a random hand gesture. Now let's move on to computer strategy play. A group of Chinese researchers found out the winner stay, loser switch pattern. This strategy can beat the people with the pattern found. If you win or lose, follow this pattern. Scissors, paper, rock, scissors, paper, rock. If you tie, then follow this pattern. Paper, scissors, rock, paper, scissors, rock. In the experiment, one player plays the computer and the other is a normal player. And this is the generator. The app asks for what A played that round and what B played. Then it gives player A a gesture according to the strategy. This is the results sheet for the experiments. The results sheets collect the 4 types of experiments, which when you're playing, the player names, whether the player's computer or not, and in the middle, the hand gestures of both players, and on the really right, the results that decide who wins or if they tied. In total, we conducted 15 sets of experiments and collected 360 rock, paper, scissors game results. And the photos on the bottom are me and Jason collecting data at Very Fun Summer Camp. After we collected the data, we put them into Google Sheets and turned them into bar plots. Due to a time limit, I'm only going to share 2 interesting results. This is the sum of hand gestures in normal play. The most popular hand gesture was rock. That agrees with previous research. Scientists say people like rock more than any other because it is the easiest gesture to make and it looks more powerful. Second came scissors and third came paper. That conflicts with previous research. This is the strategy play results. In the strategy experiment, player A played computer and player B played normal. In the bar chart, it shows that players A won the most, 63 times, and players B won 37 times. So the strategy does work. These are our conclusions and thinkings. So in normal play, the 2 players won about the same time, like same times, and in blind play, the blind player won more. And in strategy play, the computer strategy exploiting winner stay loser switch pattern works. The samples in this experiment are from Very Fun Summer Camp, family and friends of me and Jason. We tested about 14 kids in total. The sample size is very small, and it cannot represent all of the kids in the world. To ensure that our conclusion is more reliable, you have to do it more times. For example, 100 more times for all of the experiments. We want to give thanks to Very Fun Summer Camp teachers and kids for giving us the opportunities to do the experiments, Raymond Fung for helping us with coding random and strategy app on Scratch, Hannah for providing us with experimental data, and last but not least, Chan Jung for helping us creating the result column. Next time, I bet I can beat my brother in rock, paper, scissors. Thank you. And that concludes our presentation. Thank you for listening. Do you have any questions?
Judges, you may Judge Jocelyn Pan, you may ask the questions.
Yeah, let me say something. It's really great. Okay. I think I learned a lot. So it looks like people like rock, then scissors and paper, right? So it's great learning. Okay. And also for elementary school students, you have done a tremendous work on this PowerPoint. So great. So for the computer thing, I noticed that you're using Scratch. Is it right?
Yeah.
So how you generate a random number or a computer number?
So, let's see. Okay. So the generator was coded by Raymond Fung, Jason's brother. And
Okay. So which part is done by you?
So the app was made by Raymond.
Okay. Okay, thanks. Yeah, I think the PowerPoint is very good. Okay.
Thank you.
Dr. Pan, you may ask the questions.
I actually have a comment. First of all, Alicia, this is a wonderful presentation. I love all the visual effects you have. And then also during the presentation, you kind of convinced me to try, like, am I giving a rock more than scissors and, paper? And it looks like you're right. I didn't recognize that I was doing that more often than any other hand gesture. My question is that when you say the sample size is small, could you define a little bit about what sample size means for me?
Sample size is 14 kids and three. Seems like the sample size is 14 kids and 360 parents.
Yeah. And it's I know that this is a great experiment, and like you said, for any research experiment, we might face sample size being small. And I would volunteer if you need some sample, or data. I would love to try out your strategies with my own kids. But thank you for answering my question. Thank you, Alicia.
Okay. Thank you.
Judge Newell, do you have any questions or comments?
Hi, yes, really quick. So excellent, very, very excellent, Alicia. I have a question. How long did it take you to conduct your research?
About 1 month.
Okay. All right. Wow. Briefly, can you explain to me your arc? How did it go over those 30 days? How did it start, middle, and end? Maybe in 3 points.
So first, Raymond Fung coded the generators, the 2 generators, and then we used and then we went to Berry Fun Summer Camp to test, to get some data, and then put them into Google Sheets and turn them into bar plots. And then we made the slides, and that's about it.
Wonderful. You guys did an excellent job. Do you think, I really like, I've written a couple of things that I won't go into now because there's a place for them in your notes in the judge form. But I will say this, it was such a fun project and you were able to be very concise, very exact with your words and your slides, so much so that you were able to get all the way to the end and include acknowledgements, which are very important. So a thumbs up for being able to present and acknowledge. Very well done. I've always thought this about rock, paper, scissors, shoes. So it's nice to have someone confirm my suspicions. I'm very good at playing rock, paper, scissors. And it's because I have a feeling that most people always go for rock first. And now I know the truth. So thank you for that. And then lastly, do you think there's a way that over 30 days that perhaps you can get a larger sample size in the future? Maybe, think about it. So other than that, you acknowledge the fact that you had a small sample size. So I give you a high five for that. Because the moment you said you collected 15, I was like, but then you were like, but I know 100 is what it's supposed to be. So I was like, oh, okay, I could sit back down. So very well done. Thank you so much. And I will submit your form, and that's all on my part.
Alicia, I have my own question. If it's a tie, do you switch?
What?
If you tie with the opponent in rock, paper, scissors, like let's say the opponent has rock and I have rock as well, do you switch or do you stay?
Switch.
Okay, thanks. Now judges, please submit your comments and notes. So the data was right. One of the participants said they do go for rock first.
Next time I'll go for paper. If I
Paper
make
seems like a good option. You have a higher probability of winning with it. Okay, judges, are you guys done with submitting the forms?
Yes.
Okay.
Yes.
Noel, are you done?
In a moment, but you can
Okay.
continue. I'm pretty much.
Okay, I'll start on my next presentation. Okay, what comes first? The chicken or the egg? Or the egg or the chicken? Or the chicken or the egg? To be honest, I don't know. One thing I'm certain is I am first. I'm always first in everything. Back on point. I've always wondered how the egg and the chicken correlate. How long does the egg take to go to a chicken? How long does a chicken need to lay an egg? I have no ideas about these questions. But however, today, Jing Han Zhou and Celine Che, Eva Zhao, and Lan Zhao will explain to us how the egg and chicken go around and how they work together. They will present their project at the CHIC. So without further ado, let's give them the spotlight.
hello.
Not yet.
Presenting. Hello everyone, my name is Celine. I'm a second grader and I am attending Stratford schools.
Hello everyone, my name is Jing Han. I am 8 years old and I am also attending Stratford School.
Hi, I'm Eva. I'm in 4th grade and I'm attending the Aloni school. Hi, my name is Ian Zhao and I am 6.5 and I'm attending Aloni school. And together we are the Crystal Team. Today we are going to present an engineering project called From an Egg to a Chick. You want a pet? Dog? No. Cat? No. Fish? No. Rabbit? No. Chick? Yes. Let's do it. Ian, go. That's Ian here. According to our research, it usually takes 21 days for an egg to hatch. Our engineering goal is to conduct an experiment. We want to see if we can recreate the hen's environment to hatch 24 fertile eggs in 21 days using an incubator. But how do we do that, Ian? First, we must follow some science instructions. Now, let me pass on to Eva. She will explain the methods. Hi, it's Eva here. I will present the methods. First, we purchased fertile eggs which are laid within the past week. Also, our incubating conditions were very important. Our temperature was about 99.5 Fahrenheit, and the humidity was about 45% to 55% through day 1 to day 18. Then we adjusted our humidity to about 65% to 75% through day 19 to day 21. Last but not least, if you don't have an incubator that will turn your eggs for you, then you'll need to turn your egg once every 2 hours a day. We were trying to mimic the real condition of how a hen hatches an egg. Now let's let Jinghan present the results.
Hi, I'm Jing. Today, I'll present our project results. We prepared 24 eggs, 15 eggs successfully hatched in about 20 to 22 days. The success rate is 65%. It's slightly lower than our hypothesis because one egg was accidentally broken before incubation, 4 eggs were not fertile, 4 baby chicks did not get out of their shells in time. In the future, to incubate eggs faster and candle eggs in the 7 to 10 days to ensure fertility. We hope to improve our project results. Thanks for listening.
Thanks for listening.
That was a great teach. I love how you guys came together and did all these thanks for listening, all that stuff. It was really cute. So now judges, do you have any judges you can ask questions? Dr. Pan first.
This is such a fun presentation. I cannot stop, like, it really catch my eyes. I just keep going, kind of wait, like the next slide. And also that all the presenters, one thing I wanted to make a comment, because you are in 2 different locations, you did a great job switching when the next speaker is coming up. And I really like the fact that you let us know who you are every time when you speak. Let's say this is Eva, this is Jinghan, this is Ian. And then also I have a comment. I have a 6-year-old at home. Ian, you did a fantastic job. You're only 6 years old. You made your message loud and clear. So I really enjoyed the presentation. One question that I have in terms of the hypothesis, who can tell me what hypothesis mean? Jinghan?
Hypothesis, like
Yes.
in the past, when you guess what'll happen, and yeah, that's what
Excellent answer. Thank you. Thank you. That's all I have.
Next Judge Noel, you can give your comments and ask questions.
Thank you so much, Aaron. So Eva, Ian, Jinghan, and Celine, congratulations. You guys did some great teamwork. I did not know you guys were in 2 separate locations. I just figured maybe they're in 2 different rooms. It feels like you guys are all together and very cohesive. So double thumbs up for that. Also, very young to be doing this. So that's very exciting for me to see such big young brains at work. It's a very fun experiment. I have so many questions. What happened with the chicks after they hatched? Okay, that you don't have to answer. I'm just curious. And then also the ones that hatched after the deadline. I'm glad that you had a deadline. So that's nice that you were able to include the data of four didn't meet the deadline. Who knows, perhaps they did hatch. And you also counted an egg that broke at the beginning. So I appreciate you being able to, how do I say this? Keep it, Dr. Jen, can you help me? What's that called? When you count even the big, like for example, an egg that didn't make it into it, but that was the original size.
Oh, the sample size?
Yeah.
Yes.
Like you didn't dismiss the one that broke. And just,
Right.
It was included. That's important. So thank you for that. And then I do have a question for the team, and any one of you can answer it. What are some of the obstacles that you had to overcome, and how did you overcome them?
Uh,
I see Jing. Yeah, go ahead.
So like sometimes when we're in sleep, the humidity keeps going up, like lower than 45%, or like in the next day just goes like lower than 45. So every day I need to put water inside the incubator.
Do you think that's a variable that is needs to be can be controlled more, or is it because of the weather or because of the machines? And then you overcame it by adding more water?
Yes, because like the
because sometimes the water is too much.
Okay, very good. Thank you.
Yeah,
Judge Tony.
great work. You know, this make me think about when I was young, I was hatching chicken with my dad. Okay, it's always very joyful when I see those chicken break eggs. So let me ask you one question. So what is chicken right now? Okay, what you gonna do with those chickens when they grow up?
They all died. Not all of them, Ian.
Really?
well, your cheeks.
Okay, that's too sad to hear. Okay.
Not all of them, just only some died. Yeah.
Okay. Yeah, but I think it's definitely is a good experience. You know, at you guys' age, and this is definitely a good experience. Maybe next time you can do even better. Okay.
Say thank you.
I have my own question. Are you guys still raising the chicks?
No, all the chicks have already came out.
Do they still exist, or
Yeah.
are they your pet now? Oh, okay. That's cool. I have my own pet. I have my own pet birds too. Okay, now Judge, please submit your your comments, and I'll begin after a moment.
Yeah, I submitted.
Me too.
Doc,
Yeah, I did.
Miss Noel, did you submit?
Yes, in a moment.
Okay. I guess I'll wait a moment and then I'll begin my presentation. Okay. Okay, I'm going to start my presentation now. Let's get into the next presentation. Boats, boats, boats. You either love boats or you hate them and you throw up a lot. I've never really been on boats a lot. In fact, I've only been on them once, but I didn't throw up, unlike the other people right next to me. Yuck. Anyways, our next project talks about a super boat. A boat that has no limits, can do everything. Or at least that's what I think it is. Let's let Benjamin Ye, Zachary Liu, and Vincent Champ start performing. Without further ado, let's welcome them to the stage.
That is not it.
Hello everyone. Our superboat presentation credit goes to Benjamin Yi, Zachary, and me, Vincent Chai.
Are you guys gonna share a screen or anything?
I'm gonna share.
Okay.
Okay. Just let me go
Um, superboat presentation. My name is Vincent Chai, and I'm gonna attend third grade. My experience was Scratch. Our project is about superboat. This is our team member, Benjamin Yi, Zachary, and me, Vincent Chai. The project idea was got from Ben and Zachary. Next, Ben will talk about how he drew the boat. Zachary will how we drew the boat.
How we drew the boat. This is how we draw it.
Wait, no!
Wait, you flipped it another page.
Sorry.
How we drew the boat. We first used a circle command to draw the bottom part of the boat. Then we drew a flag to show that it's actually a boat. First, for the flag, I drew the bottom of it by just moving it forward. Then we drew the flag by going forward and then using the circle command. Finally, we went straight down to complete it. After that, we made it function and put it in a loop and make it go forward.
How I set the background. First, we tried to draw some curved lines, and put it in the same loop, but that was too hard. So then I searched how to set a background picture and then set one. Drawing a fisherman. The last step is to draw a fisherman. Drawing the fisherman was easy. All we had to do is draw a circle at the top of the boat. I forgot to put something there, and then we filled it the salmon color because that is a color that can look like someone's skin. So then we draw a 45-degree line representing the fishing pole screen. Straight. Superboat project summary. This is a summary of our project as a simulation of a boat moving. The boat can be a speed of your choice. The boat can go forward up to 480 because that's the screen size. Lastly, concluding our project, its size is 50 pixels long and 100 high. And here you can press the link to get on the repo. And here's it, and here's how it looks. We just need to read it. And if you can see this, it's right here. And that's it.
Are you guys done with your presentation?
Thank you for listening. Have a great afternoon.
Okay. Judges, you can start asking your comments or asking your questions and giving your comments. Dr. Pan first.
Great job on presenting the it feels like it's a little animation, right? Do you have another name for it? Is simulation or
Yeah,
what is it?
yeah, it can be a simulation.
Simulation. Okay, okay, good. So I think that it's really fun to watch it, especially you're showing us like a step by step how you make this happen. For me, that I don't know much about, computer science and Python, and and for me to see that you kids can generate out a very cute boat, can slide on the screen and moving forward. That's great. The only suggestion I would have is that maybe it was just me, I missed out the first part, like why you will want to do this. What's the purpose of this project? If you can spend a little bit more time in the beginning to explain it, that will make it, at least I know, okay, this is what's coming up. So can any of you answer the question, like, what made you decide to do this project?
Well, I really wanted to fish sometime, so then I had this idea to use the boat.
So 3 of you come up with the same idea?
Can I also add?
Sure, please.
I also like this idea because I like sharks a lot and also whales. And I like the ocean a lot.
Okay. Okay. So fishing, sharks, and boating, and okay. And so it's great. I really enjoy your presentation. Another thing that I would kind of like a tiny suggestion is that if you can show the simulation that you show us in the end, and then show it in the beginning, so we know that, oh, this is the project and you're telling us how you make this project happen. And that will, sort of, this is the beginning and this is the end, and how you conclude it, and in the middle of it, just like when you're writing essays, there's the beginning of it, tell us what to expect step by step, and there will be conclusion. I feel like that presentation might be a little bit more complete than now. But overall, like I said, I really like that you can represent this in a very simplified language for me to understand. Great job, guys. Great job.
Can I say something?
Sure.
I really enjoy this team, even though I don't have Python experience. I learned a lot from them.
Oh, good.
That's really nice to hear. Now for the Judge Noel, you can give your comments and ask the questions.
Thank you so much, Aaron. Okay, so you guys looked like you had a lot of fun doing this project. Raise your hand if that's true. Yay. Okay, what were some of the things that you enjoyed the most, starting with Vincent?
I liked the color of it.
Did you get to color it yourself?
No, we did code to color it, and I did the coloring even though I don't know.
Yeah. So when you say I like the coloring of it, do you mean to say you enjoyed coding the color?
Yeah.
Yeah, that is cool. That is super cool. I'm also an artist as a hobby, and it could be a lot of fun to sit there and try to figure out what works the best for you. Okay, and then what about you, Vincent? What did you enjoy the most? I'm sorry, Benjamin.
I enjoyed because I kind of like got to code a lot, and I also got to explain a lot of things because I like to do that, and I really had a fun time coding with them.
What did you code the most?
Basically, like, I guess the
movement, I think, is what Zachary is trying to show.
Yeah, and then how we do the boat stuff.
Okay, cool. The dimensions?
Yeah.
Cool. Very cool. And then Zachary, what did you enjoy the most out of your project?
The slideshow. I really
Yeah.
like the slideshow because it looked pretty good. And
Yeah.
I'm just proud of it. I just like it.
You put it together?
No. I worked with my teammates,
Okay.
Benjamin and Vincent.
Okay, very cool. I could tell you guys had a lot of fun with this project. Let me see what I wrote. Hang on. Thank you for introducing yourselves and creating this and creating the project ideas. I also asked myself the same question as Dr. Pan. What question are you guys asking? At the beginning, I had a moment where I was like, what's the question? What is the question that you're trying to answer? So, and then also what I had some question, what is a circle command? So there are some some language that is not common for people who don't code. I wish I knew more about circle commands. So yeah, so when it comes to stuff like this, it's safe to assume that you're speaking to an audience that knows nothing. They're all 5 years old or under, and you need to explain what everything is, or at least the very foundation, like the key points. Other than that, it was very, very pleasurable for me to watch you guys, especially the smile when you guys finally did show your boat, your super boat. You guys lit up. Your faces were very proud, and that was enjoyable for me to watch. That's all I have for now. I'll include the rest into my form.
Okay.
Judge Tony, please ask your questions and give your comments.
Yes, I don't have any particular questions. I think this is a very good project. So I have only one is from any like you guys attending X camp or program school?
You lagged out. For me, you cut out. I couldn't really hear your question. Can you repeat it?
Okay, yeah, basically I was asking, have you guys attended any programming schools? And also how many time you spend in order to complete this project?
Like, so, I think we first when it was like the time when it just started, me and Zachary worked on it, and I we introduced our ideas first, and then when we spent it. So basically we worked on it probably the whole time. So
okay. Yeah. So how much time do you need to program every day or debug every day or get any help from?
We try. I try to add the stuff every day. So yeah.
Okay,
time is up for the interview part. So I hope you guys asked your questions. And now let's move on to the next presentation. Good project, guys. You know what's awesome? Bouncy balls. You know what else is awesome? Things that float. What if we combine them together and form buoyant bouncy balls? That's right. I have no idea how it works. But today, Sophia Jane is here to show us the impossible. Buoyant bouncy balls. Let's welcome her to the spotlight. Sorry, Judge, I forgot to say this, but make sure to submit your things. Yeah.
Hi, my name is Sophia, and I'm in 4th grade. I'm attending Challenger, and for my experiments, I'll be doing it on what is the effect of water density on a bouncy ball's buoyancy. I was first motivated to do this experiment when I was told that you could float on the Dead Sea. It was really fascinating to me, and I wondered what was the feeling to float on the Dead Sea. Then I decided to do more research on it. Next, I wondered, why does my brother float more easily in the swimming pool than me? So I decided to conduct this experiment. Can we make a bouncy ball float in some liquid? My hypothesis is if an object surrounding fluid is more dense than the object itself, the object will float. Some materials you'll be needing for this experiment will be clear plastic cups, water, salt, a teaspoon, a bouncy ball, and a measuring cup. First, prepare 3 clear plastic cups on a table. Pour 4 ounces of water into each cup. Don't add salt in the first cup. Add 4 teaspoons of salt in the second cup and add 8 teaspoons of salt in the third cup. Mix thoroughly in the second cup and the third cup until all the mixed liquid is clear. Pour 3 ounces of the liquid in the first cup into the measuring cup. Drop the bouncy ball into the measuring cup from the last step, then check the floating status of the bouncy ball. Do the same thing with the liquid in the second cup and the third cup. Compare the floating status of the bouncy ball in the different liquids. My results were that the bouncy ball in clean water almost sank to the bottom of the cup. The bouncy ball in the water with 4 teaspoons of salt was partially above the water, and the bouncy ball in the water with 8 teaspoons of salt floated even higher. Now you may be wondering, why does the bouncy ball show different floating statuses in the clean water and in the salt water? Well, the floating capability of the liquids are due to the difference of the density of the liquids and the bouncy ball. The density of the clean water is smaller than the density of the bouncy ball, which causes the bouncy ball to sink. However, the density of salty water is larger than the density of the bouncy ball, which causes the bouncy ball to float. More salt in the same amount of water generates a higher density of salty water, which creates an even larger floating capability. My conclusion is that my hypothesis was supported. The floating capability of liquids is related with the difference of the density between the liquids and the bouncy ball. Some further improvements I could make in the future is that I could try more types of fluids to define their density, such as water with more salt, sodas, juices, and even things such as soy sauce and vinegar. I could also change the object from a bouncy ball to a different brand of bouncy ball, bottle cap, and other light objects. Thanks for listening.
Good project. Now it's time for the judges to give their comments and ask the questions. Dr. Pan, you may go first.
I feeling honored that I'm always asked to be the first. So and it made it easier for me because I can say what I have in mind. Okay. Thank you. Thank you, Aaron. So first of all, in science, we know that it is very important for us to make it clear like what specific procedures that we do like in an experiment, because whoever gonna read your science project or paper in the future, they may want to either repeat your experiment or maybe they have their own experiment they wanted to do the comparison. So what I like a lot about Sophia's project is that you're able to make very clear, easy to follow step by step for me to want me to do like a repeater experiment and see it from with my own eyes, the difference between the salty water with different density and then the clear water. So it's amazing. I really like that. So for, this is a suggestion to our all little scientists here, is that when we do the presentation, it's super important for us to list out exactly what you do, like the research, hypothesis, procedure, and data, conclusion, area to improve. Another comment that I have for Sophia's project is like, I really like when you list out the improvement. And in fact, that when you start that slide, I wrote down like density, like on my own notes. And then you just said, well, in the future, I'm going to test different kinds of density and then etc. So it's very clear, organized presentation. You're super aware of the timing, so that's nice too. I have a question. Could you explain? I know what density is, but let's say if a child who who never heard about what density is, but maybe have some experience with density, can you explain to me what density is?
Well, like density is like uh it depends on how dense things are to how things float and sink because of the buoyant force. And like everything has a different density, and like it's kind of like the weight of an object, but it's also like not the same thing.
Mhm.
at the same time.
Thank you, Sophia.
Dr. Pan, are you finished with your questions?
Yes, yes.
Okay, Miss Noel, you can go next.
Thank you, Aaron. Aaron, can I correct you on the pronunciation of my name?
Yeah, sure.
Thank you. It's Lu L.
Oh, Luel.
Yeah.
Okay.
Don't worry, it happens all the time, and I wasn't going to correct you, but I figured why not? Well, you should know. Okay, so thank you so much, Aaron. Okay, where are you? Hi, Sophia. Thank you so much for sharing, for starting with your question and sharing your motivation. I love hearing the background of what inspires us to seek more knowledge. It's also it's good to share your motivation, because then it also motivates your audience to know, oh, that is super interesting, and I want to know more about why do I float more than my brother, or what it's like to float in the Dead Sea. Thank you for sharing your hypothesis. I do have something I want to say about situational awareness. When you are presenting, because I come from Able to Shine, and we are a soft skills educational platform. So we focus more not only on STEM, but also on when you are publicly speaking and the practice of doing so. And that is something that does need to be practiced, like piano, like all the time for years, so that we can become better and better. You just keep showing up for yourself. So one thing I do want to let you know is about situational awareness, and to be aware of your audience when you are speaking. You shared your hypothesis, and I thought it was a very good hypothesis, but I would have loved to either have you repeat it so I could make sure that I understood and had a moment to process it. That can also be done with a pause, where you say your hypothesis and stop, so that people can echo it in their mind and ask themselves, oh, okay, this is the question, or this is what I think the answer is. Or you can say it more slowly. You were speaking a little bit fast, and that happens sometimes when either we know the information, or we're excited to share it, or we're a little bit nervous to do so as well. So taking a breath, breathing, and slowing down helps with that, because you had great information. I was trying to grab at it with my ears. Like, hang on, I want to hear that. But oh, we're already on to the next thing, and this is juicy too. So it doesn't give me a chance to chew on the information. Great photo of your results. I really see the difference in the floating statuses. That is very fun to see as like an eye opener, like, oh, wow, density really does make a difference. Well done with your discussion session. Please try standing up when you're presenting. It adds dynamics to your presentation, which in turn grabs people's attention. And if you're sharing information and you're saying thank you for listening, it's probably because that's something that you would like to have, is the people's ears. And then I like how you added an improvements section. Because what is science if not on the shoulders of the ones who came before us? And we are doing exactly that, improvement. So thank you so much for that. Don't forget your acknowledgements. You did a great job, Sophia. Thank you so much. I really enjoyed your presentation.
And the last judge, Tony, you can give your comments and ask your questions.
Yeah, I think it's a very good project. And I think two other judges already asked a lot of questions and comments. I just want to add one comment on what Judge Pan's question regarding on the density. And Sophia, in fact, the density is just the mass over unit volume. Okay, so mass is definitely related to weight, just like you said. The weight is related to gravity. So mass is constant for everything. Okay, just one comment on that. Okay.
Sophia, I have my own question. Did you test if the amount of water affects if it floats or not?
No, but I can do that because if there was more water, then it can affect the density.
Okay, thanks for answering the questions. Now that all the presentations are done, judges, please check your scores and we'll give you several minutes to do so. Oh yeah, participants, I don't think you have to stay here. You guys can leave if you want. You can check the scores online.
Oh, do they have to stay for the reward ceremony?
Yes,
Or,
it's
yeah.
the lobby.
Oh, they had to stay. Okay.
Yeah, okay.
How can you, some people might have already left. How would you let them know?
I'm not really sure.
So actually, when the meeting begins, they said the ceremony will start from 4:30. So yeah, they probably will come again at 4:30 because it's now right now it's still 30 minutes away. So I think yeah, it's a very good at least a very good MC and very good presentation for everybody. Yeah. So yeah, judge, if you want to change the your judgment or the score for any presentation, please do so. Otherwise, please come back to this meeting room at 4:30. We will have announced the winner.
Okay.
Thank you.
Thanks for the compliments.
Show your cheek.
And thank you very much for Dr. Pan and Lou and Dr. Shaw for the judge.
Thank you. I see chick, right? Maybe.
Yeah, that's chicken.
It's so big now.
The chicken.
We're happy to see it's well and alive. Yay. What did you name it? Did you name it?
Squeaky. Since a long time ago, it didn't squeak a lot.
Do you know how to put it to sleep?
Oh, no.
You put it on its back and you pet their beak and then they go like this.
Well, there are other ones, and I know all their names, but I just can't show one.
I love it.
How many more do you have?
Well, let me see. I have 6 more, so in total I have 7.
That's nice.
That's a
I
lot of
have 2
eggs.
of my birds.
My birdie.
Yeah. Do you know which one is hen, which one is rooster?
Yeah, this one have a trunk already.
Oh.
See here.
Oh.
Curvy.
Crest.
Yeah, crest.
Hmm.
Oh, no.
So everyone, great presentation. And thanks all of to our MC and also the judges. Thanks for your great work. And then we will have our award ceremony at 4:30. So right now, maybe if you guys wanted to know each other, you can turn on your video and free to talk. And also you can take a short brief, okay?
Okay, I'll be taking a short break. I'll be back. Bye.
Okay, thank you, Erin.